we need to take a look at the different motor starting ideas that we explored in the last lab. So the first one right here is we had Estop normally open. So I take a look at the Estop normally open. Let's see what happens. We had a start button that was wired in normally open. We had a stop button that was wired in normally open but program closed. And then we had a motor starter and the motor starter holding itself. So first of all, if you take a look at this, because this is shown as a close contact, it's automatically always true when we start. So if I'm not pushing the stop button, this is just automatically going to be true. When I push the stop button, it went false. But let's just say I haven't pushed the stop button, so this is just automatically true. Which means that even if I don't have a stop button actually wired into the PLC, it doesn't even need to exist, then this right here is automatically true. If I do wire in a stop button, that doesn't change this. This is still true, but I could make it false by pushing the button. So how does this work? I would hit start and it would come on. That's true. This is always true because I haven't pushed the button. The motor starter would become true, and then I release the push button and it would go off and I would have memory. So once again, this is just automatically true. So I unplugged the stop button. It's not going to change this. I have to create a signal by pushing the stop button, which would toggle that back off, and that would turn this back off. So what we're trying to say here is that when I let up the stop button, that goes back to true. So this is not a good way to start a motor starter, because actually removing the stop button doesn't change whether this instruction is true or not. Okay, the next time we look for the Estop to be wired normally closed. So we had a start button, it's not pushed, so it's open. We have a stop button that's wired normally closed. That means that it's getting a 1 in the data table, so it's going to be automatically true whether we push it or not. Okay, but the motor's not started because we haven't done this. So when I push the start button, that becomes true. The stop's automatically true because it's wired normally closed, even though it shows an open contact there. The motor starter would start, and then I let up the stop button, and I have my truth there. In order to stop the motor, I have to remove the signal, input 1 1, because there's voltage there, and by pushing the stop button, or let's say I had a bad wire, or you remove the stop button or something like that, that is going to cause that to go low, and then the motor starter would go low. Okay. The next thing we did is we took a look at using the motor starter, a fictional contact associated with the motor starter that would seal in the circuit. So once again, the stop button is wired normally closed, so it's going to push 1 in here and change state and make that a true. There's a 1. So if I hit the start button, the motor starter comes on, and then I release the start button and I have my path. And then what I did is I came over, or what we did is we pulled the voltage on the motor starter, the cable. So the motor starter went off, physically the device. But that doesn't affect the logic here, because this logic doesn't really care if there's something connected in output 2, 1 or not. If there is something in output 2, 1, it's going to turn on. So just because we unplugged the motor starter, that doesn't mean that this goes low. This bit is still hot. So we unplugged the motor starter, and then as soon as we plugged the motor starter back in, because this still is true, because it was holding itself, well, the motor starter just started right back up. Now that's pretty dangerous, because the motor starter went down and then it got the connection back. Maybe it was loose wire or something, and it started right back up. So if you were troubleshooting it, then you're in trouble. So this circuit here is not a good way to latch on a motor starter because this latch here, this fictional, is internal, and this contact doesn't really monitor the status of the motor starter because we don't know what's actually hooked into this or not. Okay? So if we look at the next one where we use the auxiliary, we hit the start. The E-stop was wired normally closed, so that made that true. The motor starter comes on. And hang on. When the motor starter comes on, notice that this didn't come green. This is going to come true, you know, a couple milliseconds later, because when the motor starter comes on, it actually closes a set of contacts that are real, that are located on the motor starter, and so that those contacts close. Then when I let go of the start bit, I have my path. Now what happens here is this time when we came over and I unplugged the motor starter, okay, so before we said this PLC doesn't really care what is plugged into output 2-1, and it doesn't. But if we unplug the motor starter, what we did is we didn't affect this bit. What we did is the motor starter did shut off, not here in the logic, but in real life. And when the motor starter shuts off in real life, then this contact that is an actual part of the motor starter shuts off in real life because we kill the power to the motor starter. Then when we plug the motor starter back in, this went off because we broke our memory circuit here. So when I plug it back in, the motor starter does not start back up because the auxiliary, which is real, killed the memory. Another way we could do this is we could use the starter overload. So the starter overload is a normally closed contact. It's wired in normally closed, so because it's normally closed, this is going to be showing as true. The stop button is also wired normally closed. So what happens here? I hit the start button. The motor starter starts. A couple hundredths of a second later, when the coil pulls in the contact, this closes, and then I let go of the start button, and it's off. So I've got a little path here. Now, if the motor gets too hot, what happens is the overload switches states. From being a normally closed, it opens, which in open, you put a 0 in here. This is going to open back up, and now we've broken our logic. So the motor starter is going to go off, this bit. And because the motor starter goes off on the logic, the real life, the motor starter that's wired in to the module is going to shut off, which means that the real starter auxiliary that is part of the motor starter is going to go off. So that this has doubly turned itself off, the starter auxiliary and the starter overload. Now the starter overload is auto reset and it cools down, and then it comes back on, it closes, causing this to indicate that it's true. We don't have an automatic restart because we had broken the memory in two cases, when this went down and when the starter went down. So those are a couple things that we talked about starting a motor to try and be safe.